Dear students, welcome to Cute Chemistry. We are in part 3 of chemical reactions and equation, and in today's session we are going to study about chemical equation. So what is meant by chemical equation? The way of representing a chemical reaction in the form of symbol or chemical formulae is called as chemical equation. We know to represent a chemical reaction as word equation, but we have to represent the chemical reaction in the form of symbol as well as chemical formulae. Then the equation will get complete. So let us take one example. Zinc metal reacts with sulfuric acid to produce zinc sulfate and hydrogen. So this is the reaction. So now I am going to represent this reaction in the form of word equation. So it will be zinc reacts with sulfuric acid to give zinc sulfate and hydrogen gas. So in this, zinc and sulfuric acid are the reactants, and then zinc sulfate and hydrogen are the products. So now we have represented this chemical equation in the form of word. Now I am going to change this in the form of chemical symbols as well as formulae. How to represent it? So this formula for zinc or the symbol for zinc, it will be represented as Zn. Zn is the formula for zinc, and then the formula for sulfuric acid is H2SO4. 2 hydrogen, 1 sulfur, S is for sulfur and O is for oxygen. Altogether it will combine to form sulfuric acid molecule. So group of atoms combine to form a molecule. So sulfuric acid molecule, hydrogen, sulfur and oxygen will be there. When this two reacts together, we will get zinc sulfate. So the formula for zinc sulfate is ZnSO4. Zinc, symbol for zinc is Zn, sulfate SO4, sulfur and oxygen, 4 atom of oxygen. So the formula is ZnSO4, zinc sulfate molecule, and then along with that we are getting hydrogen also. So the formula for hydrogen is H2. Hydrogen, the symbol to represent hydrogen is H, and hydrogen will always be available as diatomic molecule. So the formula for hydrogen is H2. 2 hydrogen atom combine to form hydrogen molecule. So this is the equation, that is the chemical equation for zinc reacts with sulfuric acid to give zinc sulfate and hydrogen gas. So we have written a chemical equation. Zinc reacts with sulfuric acid to give zinc sulfate and hydrogen. Always in a chemical reaction, the equation has to be balanced. Do you know why? Why the equation has to be balanced? In general, no molecules or atom can escape out from the reaction. Energy will always be conserved, which means it cannot escape. So initially whatever the amount that we are taking during the reaction, at the end also we will be getting the same thing. So the number of atoms or molecules which is participating in a chemical reaction, which will be equal to the number of products which we are getting at the end of the reaction also. Now we have represented a chemical equation, that is zinc reacts with sulfuric acid to give zinc sulfate and hydrogen. So the next step is we have to check whether the equation is balanced or not. So before going to that, I will give you one example. Let us take one jar. In this jar I have 4 balls, 4 yellow color balls, and this yellow color balls weighs around 5 grams. And then I have another jar. In this jar I have 3 blue color balls, and this 3 blue color ball weighs around 3 grams. So now what I am going to do is I am just going to put this together, that is 4 yellow balls and 3 blue balls together in a single jar. So what will happen here? So I have 4 yellow balls as well as 3 blue balls. So total I have 7 balls. So in a combination of blue and yellow, and the weight is also same. So it will be the addition of these two. So the weight is 8 grams. So from this what we have understood is, initially whatever the amount that we are taking in a reaction, that will remain same at the end of the reaction also. In another word, the number of atoms or molecule which is participating in a chemical reaction will remain same at the end of the reaction also. So which means it is always balanced. That is, reactant side and the product side will always be balanced. It will be equal. So this can be given by a law called law of conservation of mass. So what is meant by law of conservation of mass? Energy can neither be created nor being destroyed. The energy can be transferred from one form to another form. So this is the law of conservation of mass, which means the number of atoms remains same. Energy can neither be created nor being destroyed. It will be always conserved, and one form can be converted to another form. There will be change in the state of the reaction. So this is called as law of conservation of mass. Now we will check whether this equation obeys law of conservation of mass or not. If an equation obeys law of conservation of mass, then it is called as balanced chemical equation. If an equation doesn't obey this law of conservation of mass, then it is an unbalanced equation. The equation has to be balanced. Now we will check whether this equation is balanced or not. So for that we have to follow few steps. First step is we have to write number of atoms participating in this reaction. So we will write like this: zinc, the formula for zinc is Zn, and then hydrogen is there. So we will write hydrogen. You cannot write H2 here because we are going to calculate number of atoms participating in this chemical reaction. So we can write H, and then sulfur S, and then oxygen O. So these are all the elements that is involved in this chemical reaction. So we can check from both the side, that is from the reactant side as well as the product side. So here reactant side and then product side, whether it is equal or not. Zinc, so number of atom in this zinc is 1. Only one zinc atom is involved in this chemical reaction. Here if you don't have any number, it seems to be 1. Only one atom of zinc is participating in this reaction. So 1 from the reactant side. Now we will check the zinc in the product side also. Here also we have Zn, and Zn doesn't have any subscript here, and it is understandable that there is only one zinc atom. So we can write 1. And the next one is hydrogen. So here in the reactant side we have 2 hydrogen. 2 is written as a subscript, that is taken into account. So 2 hydrogen atoms involved in this chemical reaction. You can check the product also. Here also we have 2 hydrogen. So the number of hydrogen is 2 at the end of the reaction. Next one is sulfur. So in the reactant side we have only one sulfur atom. Only one sulfur atom. Here also sulfur doesn't have any subscript. So it is 1. So one sulfur atom is involved in this reaction. At the end also we have only one sulfur. Don't get confused by seeing this SO4. So sulfur also 4. So this 4 is only for oxygen atom, not for sulfur. So sulfur remains 1 only. So yes, 1. Then oxygen is, in the reactant side we have 4 oxygen atoms. So 4. And in the product side also we have 4 oxygen. Now we can check whether the equation is balanced or not. Zinc, in the reactant side we have 1 zinc atom, and in the product side also we have 1 zinc atom, which means zinc is balanced. And then hydrogen, in the reactant side we have 2 hydrogen atom, and then in the product side also we got the same. So which means hydrogen is balanced. Next one is sulfur. we have one sulfur atom in the reactant side and one sulfur atom in the product side also. So which means it is balanced. Next one is oxygen. We have 4 oxygen in the reactant side, and at the end, that is in the product side, we have 4 oxygen, which means oxygen is balanced. So all the atoms which is participated in this chemical reaction is same, remains same at the product side also, which means the equation is balanced. This equation obeys law of conservation of mass. Let us take another example. Here hydrogen combines with oxygen to form water molecule. So let us write chemical equation for this. Hydrogen, so the symbol for hydrogen is H, and hydrogen always remains as a diatomic molecule. So the formula for hydrogen is H2. This hydrogen combines with oxygen. Oxygen also, the symbol to represent oxygen is O, and oxygen is also a diatomic molecule, that is 2 oxygen atoms combined to form O2. So hydrogen and oxygen reacts. At necessary condition, it will produce water molecule. So the formula for water is H2O. Now we have to check whether this equation is balanced or not. So for that, the same thing we have to follow. I will write the number of atoms participating in this reaction. Here we have hydrogen and oxygen. Only hydrogen and oxygen is involved in this reaction. We'll check from reactant side as well as product side. So in the reactant side we have 2 hydrogen atoms. So I will write 2. And in the product side also we have 2 hydrogen atoms. Next one is oxygen. So in the reactant side we have 2 oxygen atoms, and in the product side we don't have any subscript here, which means we have only 1 oxygen atom in this reaction. Now we can check whether it is balanced or not. So the number of hydrogen involved in this reaction is 2. At the end we are getting the same hydrogen number, which is 2, which means hydrogen is balanced. Now the next one is oxygen. So initially in the reactant we have taken 2 oxygen atoms. At the end we are getting only 1, which means oxygen is not balanced. So we have to balance oxygen. So now how to balance this equation? We can just multiply with simple whole number or smallest whole number. So we'll start with 2, 3, 4 like that. So anyhow 1 is already there. So we can start multiplying it with 2. Where to multiply? Because here we know that oxygen is not balanced, but which side we can multiply, whether it is from the reactant side or at the product side. Which side has less number or less atom, in that side you should multiply the whole number. So here we know oxygen in the product side it is deficient, so we don't have the equal number of atoms, so we can just multiply 2 here. When you multiply 2, then you can see whether it is balanced or not. Again I will be writing the same thing. We'll check whether the number of reactants and the products are same or not. Hydrogen, in the reactant side we have 2 atoms. Now after adding this 2, that is number 2, we have to check how many atoms are there. So when this 2 is put in front of this water molecule, this 2 is common for hydrogen as well as oxygen. So now the number of hydrogen is increased. You should multiply this with the subscript which is already present. So hydrogen have a subscript 2 here. So we will be just multiplying this 2. So what we will get is 4 hydrogen. So we have 4 hydrogen, and as I said, this 2 is common for hydrogen as well as oxygen. So we'll see oxygen also. So in the reactant side we have 2 oxygen atom, and in the product side we have 2 oxygen atom. So now we have to check whether it is balanced or not. Oxygen is balanced, so reactant side 2 and product side 2, it is balanced, and hydrogen is not balanced. You can see number of reactant is 2 and the number of product for hydrogen is now 4. So it's not possible. So initially we have only 2 hydrogen atom. How it can produce 4? So which means here in the reactant side there is a deficiency of hydrogen. So we have to multiply 2 here so that it can be compensated. So I will be adding 2. After multiplying 2 for hydrogen, now we can check whether the equation is balanced or not. So number of atoms involved in reaction, hydrogen, so it is now 4. So 2 into 2 is 4. Now we can check at the end of the reaction also. In the product side we have 4 hydrogen atoms. Oxygen, here in the reactant side we have only 2 oxygen atoms, and in the product side also we have 2 oxygen atoms. So hydrogen 4 and 4 and oxygen 2 and 2 in the reactant side as well as product side. Now the equation is balanced. If the equation is not balanced, we will be just multiplying with smallest whole number. So where we have to start? We have to start from 2, 2, 3, 4 like that. So we can just multiply like this in order to balance a chemical equation. In today's session, we have seen about chemical reaction, how to write a chemical equation, and then how to balance a chemical equation, how this equation obeys law of conservation of mass. In the next video, we'll be seeing about how to make this chemical equation to be more informative. Thanks for watching this video. If you have any questions, please drop your question in comment section.